Lesson 3. Lesson 3 was all about solving rational equations again. Because it's an important skill that we need to master now, we're going to spend another day on it. So solve the following rational equations. Remember, rational means a fraction. So we're working with equations that have fractions in them. Except in these fractions we have polynomials, which doesn't make them much fun. So 1 over x plus 1 over x plus 2 equals 3/4. So we need a common denominator. Everybody needs an x. Everyone needs an x plus 2. Remember, those are completely different factors. And it looks like everyone also needs a 4 here. So everyone also needs a factor of 4. So this first expression, 1 over x, it's missing the 4 and the x plus 2. 4 and the x plus 2. This next expression, 1 over x plus 2, well, it's got the x plus 2. It's missing the 4 and the x. So I'm going to multiply both the numerator and the denominator by 4x, equals 3 over 4. Well, I'm missing the x, and I'm missing the x plus 2. Those are different factors. We need both of them. We can't make that x into an x plus 2, so I just need both factors. And now we look at the numerators. 4 times x plus 2 plus 4x equals 3x times x plus 2. Using the distributive property twice, we get 4x plus 8 plus 4x equals 3x squared plus 6x. 8x plus 8 equals 3x squared plus 6x. Now this is a quadratic equation, so I set it equal to 0. I subtract 8x from both sides and 8 from both sides, and get 0 equals 3x squared minus 2x minus 8. And now we ask ourselves two questions, because I have to factor this trinomial. I set it equal to 0, and now I factor this trinomial, but I have to use the AC method because I have a leading coefficient of 3 that I can't factor out. So I ask myself two questions. I say, self, what multiplies to negative 24, 3 times negative 8, that adds to that middle term of negative 2 that I'm splitting apart? Well, what multiplies to 24? 1 and 24, 2 and 12, 3 and 8, no. 4 and 6 are going to work, but I need that 6 to be negative. So using the AC method here, we split up that middle term as plus 4x minus 6x minus 8 and group. So I can take out, not a 3, I can take out an x from the first term, and I'm left with 3x plus 4, which means I better get a 3x plus 4 over here if I did this right. I can if I take out a negative 2. So my factors, I have 0 equals, my new GCF is 3x plus 4 times x minus 2. And now that it's factored completely, I can use the zero product property, which says x equals 2, or this thing equals 0. So subtract 4, divide by 3. Subtract the 4 over, divide by 3, x equals negative 4/3. Right now those are my two solutions until I go check all the way back up here. If I plug those in, do I get 0? What values do I have to watch out for? Well, I have to watch out for 0. 0 is not good. As well as negative 2. 4 is always 4. That's never 0. So if I got 0 or negative 2, they're extraneous. None of them are, so we're good to go. We don't have any extraneous solutions, because those would be my extraneous solutions up there. 0 and negative 2, because if you plug those in, I would get 0. This next rational equation says 1 over x minus 1 plus 1 over x plus 1 equals 12/5. So I need a common denominator. Everyone needs an x plus 1, and x minus 1. Everyone needs both of those factors as well as a 5. So this first rational here is missing a 5 and an x plus 1. It's got the x minus 1, but I also need that x plus 1. Plus 1 over, well, I've got the x plus 1. I still need the 5 and the x minus 1. 5 and the x minus 1. The 12/5 needs both x minus 1 and x plus 1. So I need both x minus 1 and x plus 1. So I'm left with the numerator of 5 times x plus 1 plus 5 times x minus 1 equals 12 times x minus 1, x plus 1. Alrighty, we've got a lot of distributing to do here. 5x plus 5 plus 5x minus 5 equals, well, wait a minute, this is the difference of perfect squares here. Maybe you need to make a table to multiply those out, but hopefully you recognize that's x squared minus 1. That's the difference of perfect squares factored. So I'm going to unfactor those and multiply them together. 5 and negative 5 add to 0, so I get 10x equals 12x squared minus 12. But because it's a quadratic equation, I need to set it equal to 0. We set quadratic equations equal to 0. And I subtract that negative 10x over to get 0 equals 12x squared minus 10x minus 12. I notice that there's a GCF of 2 there, so I get 6x squared minus 5x minus 6. That's going to save me a lot when I do the AC method right now to factor this. That's going to save me a lot. I'm going to ask myself, what multiplies to negative 36? That adds to negative 5. And I'm doing the AC method here because I have that trinomial that I need to factor. Because when I solve a quadratic equation, I set it equal to 0, factor, and then use the ZPP. So what do we end up with? What multiplies to negative 36? Let me make that look like a 6. That adds to negative 5. Well, hopefully you came up with negative 9 and 4. So 6x squared, split the middleman as negative 9x plus 4x minus 6. Now we group 3x times 2. I'm left with 2x there. I'm left with 2x minus 3. My GCF here is a 2. And I'm left with 2x minus 3, which is good, because that tells me my factors are 0 equals, my new GCF is 2x minus 3, and my other factor is 3x plus 2. Don't lose sight of what we're doing here. We're solving this rational equation all the way back up here at the top, but by getting a common denominator, setting the numerators equal, and solving, I've ended up at this quadratic equation, which I'm now going to use the zero product property to solve because it's factored. Set each of these equal to 0, I get x equals, I'm adding 3 divided by 2, and x equals, I'm subtracting 2 because it's equal to 0 divided by 3. Those are my two solutions. However, I got to go check what's an extraneous solution here. What would be values that I would have to reject? X cannot be 1, because that's 1 minus 1. And x cannot be negative 1, because that would be negative 1 plus 1, which would give me 0. I don't have to reject 1.5 or negative 2/3, because that's not 1 or negative 1. So those are my solutions. That's why we have to get quick at factoring, because in the middle of this problem here, we need to use the AC method to factor a trinomial. So that's why we need to get fluent at factoring, because it's going to pop up in the middle of solving other types of equations. The third one here, I've got x divided by x minus 5 minus 2 divided by x plus 5 equals 50 over x squared minus 25. Well, this looks kind of promising because I know that's x plus 5, x minus 5. And that's a 50 up top, because that's the difference of perfect squares there. And that's good, because I already have factors of x minus 5 and x plus 5 over here. So everyone needs both factors. This first expression is missing the x plus 5. That first expression here is missing the x plus 5. Minus 2 over x plus 5. Well, that's missing the x minus 5 equals 50 over, we already have those common factors there, so we're good to go. So I don't need the denominator anymore, and I just care about the numerator. X squared plus 5x. Be careful here, you're distributing a negative 2. That negative is really part of that 2. We can't lose that when we distribute, otherwise we're gonna have a sign error and not end up at the correct solution. So I'm distributing a negative 2 in equals 50. Well, again, I've got a quadratic equation, so I set it equal to 0 and factor. X squared plus 3x. Subtract 50, I'm going to get minus 40 equals 0. I don't need an AC method here because it's plain old x squared. So I'm asking myself, what multiplies to negative 40 that adds to 3? Negative 40 adds to 3. I'm thinking 8 and negative 5 will do the trick. Multiplies to negative 40, yes, adds to 3. So positive 8 and negative 5, which tells me my solutions after I apply the ZPP are x equals 5 and x equals negative 8. Those are my two solutions here. But wait a minute, we can't forget to check for extraneous solutions. If we look at this line here, I have to look at my denominators and say, throw out 5 and throw out negative 5, because those would give me 0. So that x equals 5 down there, we reject because it's an extraneous solution. We have to reject this value here because it's an extraneous solution. So my final answer is x equals negative 8. Remember, extraneous solutions are the values that pop up in the middle of solving an equation. They solve the quadratic, but they don't solve the original equation I gave you. And finally, 2x over x plus 3 plus 8 over 9 minus x squared equals negative 3 over x minus 3. So I want to factor that 9 minus x squared, but I don't really like the order it's in because I've got x plus 3 and x minus 3. So it would be nice if I could get those to be x plus 3, x minus 3. So here's how we deal with that, and this is where we have to watch out for those pesky negative 1s. If I take out a negative 1 from here, I get negative 9 plus x squared, so x squared minus 9. So what we're going to do there is we're going to take out a factor of negative 1. We're going to take out a factor of negative 1 and throw it up in the numerator. I'm taking a negative 1 out of the denominator, so I can write that as x squared minus 9, and I'm putting that negative up in the numerator. That's a nice little sneaky trick that we can do to make our lives easier. So this first term needs the x minus 3, because the common denominator is x plus 3, x minus 3. X squared minus 9 is the common denominator, so I'm going to leave that term alone. If you want to factor that, that's perfectly okay. So, distributing, I don't need my denominators anymore. I get 2x squared minus 6x minus 8 equals distributing negative 3x minus 9. It's a quadratic equation, so whenever we solved quadratic equations in Algebra 1, we set them equal to 0, factored, and then used the zero product property. Add 3x, add 9. So I'm left with 2x squared minus 3x plus 1 equals 0. Well, I have to factor this, which means I'm probably using the AC method here because there's no GCF to take out. So what multiplies to 1 times 2 is 2. That adds to negative 3. What multiplies to 2? I don't have many choices. 2 and 1. They're both negative. So I'm left with 2x squared minus 2x minus 1x plus 1 equals 0. Now I'm grouping. I can take out a 2x, and I'm left with x minus 1. I can take out a negative 1, and I'm left with x minus 1. So my factors are x minus 1 is one of the linear factors, and the other linear factor is 2x minus 1 equals 0. So my solutions are x equals 1, add 1, divide by 2, add 1, divide by 2, x equals 1/2. Those are my two solutions, as long as they check back out all the way up here. Well, what were the values I had to throw out? I had to throw out negative 3. I cannot be negative 3. or 3. And if you plug both those into 9 minus x squared, you're going to get the same 0 in the denominator. So are either of my solutions extraneous? No, because the only values that would be extraneous are -3 and 3. So I'm good to go here. That's my final answer.